All right. Thank you so much for everyone and anyone who's joined us today for this call. With us on this call, we have a very magnificent speaker by the name of Mary Dakin. She's a proper software developer. We are so honored to be able to have her today for this call. She has been an instrumental, she has been an instrumental figure in the Elixir world, and we are grateful and we are grateful for having her this day. So she's going to share with us a very lovely topic whereby we talk about good behavior, cultivating healthy Elixir teams, and code bases. I'm certain that I'm not going to give a much better introduction than what she's going to give unto us. So, Meryl, without further ado, the floor is yours.
Thank you, Juliet. That was extremely nice introduction of me. And thank you everybody for joining me. Today, my name is Meryl Dakin. I am a founding engineer at Knock, where we build notification infrastructure for developers. I've been an Elixir developer for about 5 years now. And before that, I was a student at the Flatiron School, which is a web development bootcamp, where I also ended up being a teacher. And I mention that because I think that perspective is relevant to the way that I'm approaching things here. As somebody who switched into this field a little bit later in my career, sometimes I felt like I was missing some playbook other people had on a development team. I wasn't sure what it meant to be an effective or impactful developer, or how I could best contribute to my team in Codebase when I was a junior there. So I started pattern matching, but not the Elixir kind. This is what happens when you get your first ticket at a company or you started a new part of your code base. First, you have to orient yourself to the space. You're understanding the existing code flow, looking through old PRs, noticing the shape of functions, how the modules are named, the boundaries of the context. As you're writing the solution, maybe you're referencing the code around it and trying to keep it consistent with what's already there. And when I'm preparing for code review, I'm looking at my code through the eyes of a reviewer and trying to catch the places where I'm breaking from convention before they do. So what happens here is I'm looking for patterns and I'm trying to match those patterns. And why am I doing that? Because when we create and maintain patterns in a code base, it gives us the ability to move much faster, communicate with more clarity. It means that once you know the patterns, you can be dropped anywhere in the project and have your bearings. You can also gain speed when you're onboarding new teammates and contractors because they can start working right away in a structured code base. And the same goes for hiring. A developer without as much Elixir experience can be more productive if they can mimic patterns that already exist. But I think that maintaining strong conventions gives us more than just team efficiency. When we write code, we're translating a product vision into application, but we're also communicating with our future selves and our future colleagues. We're planning for a future when we won't be around or remember enough to explain the code when we wrote it. And this code exists in a specific time and context. It has a lot of considerations that might not be visible in 6 months or a few years after its production. It might have been the best solution at the time, but eventually it's going to have to evolve. So if we want our code to last ourselves, we want to be able to maintain it as well as we could at the time we wrote it. And I think we can all imagine a person who doesn't consider this idea in their work. You've worked with them or you've seen their name in the commit history of your projects. They've written code that works, but it's really hard to follow. And you might find yourself jumping around a lot of files. There are more abstractions than are necessary. It breaks from previous patterns in the code base. There's not tests or documentation. And I imagine the person at the time that they wrote it totally understood the problem that they were writing the solution for, and they wrote the best solution at the time. But maybe they thought they would be around forever to answer questions about it. And unfortunately, they aren't. And this is you trying to piece the mystery together. So when I think of superstar developers, it isn't this person. They can write clever code, but the code topples over when they're gone. And they can connect the code with their own mind map, but not the map of the team. So they are making themselves indispensable in a way that if they leave, their code can't be easily maintained or built upon. So I think the best thing to do is for us to divorce ourselves from our code ego-wise for the success of the health of the project and our teammates. And so I said before when I got into this field, I wasn't sure what behaviors make a good teammate or a good developer. But essentially, I think what that means is being a good neighbor to our future selves and other teammates, because we're not just writing code for our computer, we're writing it for other humans to read. So if we write code that follows the patterns already set up in the application, we know it's going to stay in our team's shared vocabulary, and we know it will stay clear as the code base evolves. I think high-performing teams of any field have this in common. They've built shared contexts and conventions, and they can communicate with much less friction. So that's the core of this talk, is implementing strong patterns in our code base and talking about the behaviors that are going to help maintain them. They end up leading to high-performing and happy teams. So we're going to start by being a good neighbor with our patterns. And what is the first rule of being a good neighbor? Good fences. So these good fences or boundaries in our application mean that each piece of our projects has a defined role. The boundaries we set and maintain within our code help all the pieces to work better together, and the Elixir ecosystem gives us an incredible set of tools to help us achieve this already. We have the Phoenix, which already gives us the separation between the web layer and the core business logic. We have the concept of contexts to contain code for specific domains. Within functions, we have tools like pattern matching to make branching logic easy and clear. And unlike languages like Ruby, where we rely on inheritance, we can use alias and import to clearly demonstrate where our functions are coming from. We have plenty of resources to draw these lines and communicate with clear intention. And yet we also rely deeply on convention to get there, because it is possible to just write all of our queries and executions in our web controllers and get some pile of spaghetti code. So let's start by talking through the high-level organization of an Elixir project and identifying the singular purpose of each of these parts. For demo purposes, I'll be pretending I'm building a simple API as one of my favorite applications, which is Letterboxd, which is a social app for finding and saving movies that you've watched or want to see. And if you want to follow me, you can at Merle, which is Merle with 6 R's. So here is how we're thinking of these layers in relation to each other. The web layer is responsible for routing and request. The service layer contains the instructions to coordinate these requests and execute them. The workers are delegated by the service layer and invoke the service layer for asynchronous work. And the schema layer contains our entity definitions and interfaces with the database. This can still be thought of as a subcategory of the service layer. So first, let's dig into the web layer. Within the web layer, whether that's our Phoenix controllers or the GraphQL resolvers, their job is to intake data, send it somewhere else, and return a result. And it should be agnostic about what that is. What we're looking at here is a controller in our app for movie data. This is the show endpoint, which should be requesting back a single movie requested by its ID. We see that it's doing validation only to ensure that what it's getting is a movie. And if it doesn't, it'll render the sad path. If it does, it'll render the movie. So let's say I want to get genres associated with this movie as well, because I want that loaded at the same time. So I can add a repo preload here, right? But if I'm looking at this code as another developer and I'm seeing that genres is being preloaded, then what I'm assuming is that that get by ID function is not doing any preloads, because I would assume that they would all be in the same place. That might be wrong. Like that get by ID, it could be doing anything. So now as a new developer looking at this, I've got to say, well, now I've got to go over here and look at this anyway, and remember that I'm preloading over here. So now we've spread out what our logic is doing here. And additionally, if I'm using this movies get by ID and preloading genres here at this show endpoint, I'm probably going to want that in other places too. So, oopsie, I went too fast. So basically, we don't want to put this logic in this web layer. We want to keep it all together in our service layer so that we know it's all contained. And it provides this consistent interface for accessing movies inside the service layer. So now the service layer. This is where we're looking at the movies module. This is what we think of as a context. It's this overarching container for dealing with movies. And this is our get by ID function. We are transacting with the database here in the repo.get. But we're not defining the query for ID here. So any large application is going to have many of these service layers. We want them to coordinate the implementation details without us needing to know what they are. So the boundaries on either side of this service layer are the intake and response and the implementation on the other side. We use the service layer to assign work, but not to form these queries or mutate data themselves. So a big reason, again, we're keeping these separate is so that it's easier for another person to read and understand what's going on very quickly. We also keep the database query here rather than delegating it to a more specific module so that they can all happen in the same place. So with that consideration, we might want to further streamline this function by nesting the preload inside of the movie module as well. So in this preload, in this service layer, instead of a repo.preload, I see movie for ID, and movie with genres. So comparing this to the previous function, I think this tells us a better story with more human readable language. In this version, I see all the data we're loading before I make the database transaction. Get me a movie with this ID and all of its genres. This also helps when I need to add something or put a filter on it. For example, if I want to never return a movie that has been archived from this database, I can just add this onto my initial query, is not archived, and this is now really easy to understand at a glance. So the purpose of these functions may change over the time, and the names should adapt with it. But in general, we want to be able to read this as another developer coming in and quickly get an idea of what's going on here. So now let's move into this query layer in the schema. So this is the movie module. The first thing I see here is the actual structure for the data of this movie, the name, release year, relationships, describes everything we need to know about this entity, and it gives us a mental map for this entity's domain. It doesn't perform any executions to the database. We don't need to interact with that here. It's just a static description. We also keep ecto queries in this module in the databases, in the code bases that I've worked on. And this is what I was mentioning before, that it's easier to keep these definitions all in one place rather than reach into like repo.preload always in that service layer. So another convention that I want to mention is this like for and with convention when we're naming these. This consistent naming is really helpful when we are looking at these functions and trying to understand how they're composed. So as an example, we're looking at this pipeline of functions that we're using to filter and query movies. This is a list all function. It takes some parameters, and we're looking for a movie with a release year, feature length, and genre, and we're preloading the genres because we decided we want those available no matter what. But these names make it kind of hard for me to understand what's going on, especially the with genres naming. It's like extra cognitive load for me to understand, like, why are we naming these so similarly? What is this telling me? It's a little bit harder than it needs to be. So following like a more consistent naming structure, we have like this idea of for a release year, and then we kind of understand that that's like a specific year. Is feature length, like adding that Boolean instead of what was before just feature length. We know that this is like not a short film. And then for genre tells us it's going to be filtered by that genre, and with genres tells us it's going to be preloaded with those genres. So just understanding that anytime we're reducing cognitive load, it makes us faster, more productive. I don't need to open up those files to understand what's going on because I already have this shared understanding of vocabulary that I've created with my team. So the last layer we're going to talk about is the worker layer. This is an example of a worker we might have in this app. Its job is just publishing Twitter reviews whenever a user publishes a review to Letterboxd. So we're using Ovan here. It's a job processing library in Elixir. And here we're saying that when this job is queued, it's going to get a review ID. Then what it needs to do is reach out to the reviews service layer to get the content and reach out to the Twitter deliverer module to handle the actual sending. So workers should be invoked within service layers. Notice we're not making database queries or transactions here. Those are still contained in the service layer. They are just a vehicle for accomplishing this asynchronous work, similarly to the service layer. And again, the fences are looking something like this. The service layer is delegating to a worker. The worker asynchronously delegates back to the service layer. So maintaining the separation of concerns is the entire team's responsibility. If the code base has strong patterns and naming conventions, it's much easier to guess where new functionality fits in. And we can also help reinforce this by making code organization part of our PR reviews or architecture designs. It's especially helpful when we find patterns that diverge, so we can act on it by writing up a ticket, adding it to do, talking about it in our engineering teams. It's going to be imperfect, but writing down which patterns you want to use somewhere with other developers is going to help other people know which ones we're going with. So now let's get into the meat of these modules and talk about functions. Let's first name an intention for writing functions. We are telling a story of data transformation. We want a story that is human readable. We want to lower the cognitive load as much as possible. Object-oriented programming describes the world through objects and their relationship to each other. Functional programming rather sees the world as acting on data, a series of data transformations. And that is how ideally we want to model our functions, so that we can tell a story to other developers about how this data is changing. The tools I want to talk about here that help us tell this story are pipes and pattern matching. Starting with pipes, I want to first show a function that misuses them. We're going back to our letterboxed example, and here we have a context for lists. Lists are user-created lists of movies they want to suggest to other users. So let's say we have a function that removes an entry from the list. Anytime I remove a movie from the list, there are several things that need to happen. I delete the association, I record an activity, and maybe I update the genres for the list. It is totally possible for me to write this as a piped function, but only if I write the internal functions in a way that specifically takes the previous arguments needed for them. So that might be like this. Delete association takes a list in a movie and returns both of those. We use that list to potentially update the genres, but we transform the list itself. We're adding or removing associations based on the movie that's passed in. Then we return the unchanged list and unchanged movie because our next function needs it. And then we have this add activity function that takes the list and movie and an additional passed in user and does not operate on any of them. It just gives us an okay. Nothing about the data we passed in was transformed in any way that we would have expected. So even though this is technically possible, like what we were mentioning before, like it's totally possible to write our functions this way, it's not telling the story that we want to tell here. It's not operating on the same data all the way through. It's getting convoluted. So we can compare that with a function that does tell the story that we want to describe to our other developers. This is a different function. It's a query that generates tags that have already been added from a list. So we start with the list itself. From this list entity, we get the tags. Then from these tags, extract their names. And now we have a list of these string names. And we perform an operation on those names and finally join them into a single string. We can follow this story much more clearly, understand it has a single purpose. Each function is separated to tell us what we're doing, but each is also working directly on the result of the former. And this is clearer because we know when we see this pipe, we're going to be seeing a transformation of some data into a different version of it. And we aren't hiding any side effects in these functions. So going back to the remove entry function, I still need this to happen, regardless of whether I use a pipe or not. So I will choose a different tool. I can choose my with operator. And this is indicating now to other developers that each step needs to happen before moving to the next step. So basically, all of these are just tells to other people about how this is working, about how we want to use these. And obviously, it has technical implications as well. But the main concept that I'm talking about here is just like the communication of our code to other people. So function composition with pipes is really only worthwhile if we're doing it to convey to another developer that we're seeing a story of data transformation. The takeaway is choose the right tool for the job and also for what it communicates. So let's look at pattern matching now. There are a lot of uses for pattern matching, whether you're writing in a recursive function or using it to guard against bad data. But the point that I want to hit on is the way we use it to communicate intention to other developers. Here's our movie's context where we have two function heads for toggle watched. When a user indicates they've watched something, we record it on the user movie module. For our function head, we pass in a user movie to it, and it shows the branching logic we would expect. If watched at is nil of the user movie, we're going to add the current timestamp. If it doesn't match that first head, we know that watched was filled, and we want to reset it to nil. So here we're using pattern matching for a specific purpose to convey that there is branching logic based on the data coming in. But let's look at a situation where pattern matching makes it much harder to know what's going on. Here's where we're determining permissions for an action in our system. This can do function takes a role struct and an action, and then it just goes down the list and matches. And this totally works, right? The computer understands this very well, but as a human, this becomes very difficult to maintain and to parse. You have to remember what pieces of data are coming in. You have to scan a long list with your eyeballs and figure out which function it's going to. It totally indicates branching logic, but it does not help us to understand what's happening. When I'm coming in here maybe to debug something or to like get data for my PM about how this works, it is way too hard to use. So some rules of thumb that we're employing with any of these patterns is it telling a clear story about the data? Does it enable others to quickly and clearly understand our intention? And if not, we can think about how to better structure our data and the way it's flowing through our system. So a better way to use pattern matching for the last example is just a pattern match on the role and keep the permissions in a list or a map. And this makes it easier for you as a developer and other people as a developer to glance at this and get this relationship in your head a little bit better. So now I want to talk about documentation. I think of documentation as clues. It helps me understand the kind of data I should be expecting, the intent of a function, maybe even the overall architecture of the system I'm working in. So tests obviously are first best clue. The assertions are a place that I look all the time to understand what someone else intended for the code that they wrote. It's kind of like a message to future developers of this is what was my intention at the time. Our docs and module docs are also doing similar work. Module doc is there for a quick overview of the module's domain, and then our docs give us a description for our public functions. Type specs can sometimes feel extraneous. And we don't always use dialyzer, I think, in our code bases, but it does give us really good guideposts, especially if you are just kind of trying to debug something and understand your flow of data through your application. I think that they can be very useful. Code commentary, people have lots of different feelings about this, but I would rather underestimate how clear my code was and just give some comments about it. And I would rather other people do that too. And then lastly is internal documentation. These are things like a tech brief, decision logs, diagrams. We do a lot of video demos at Knock, which has become invaluable when I'm going back to understand the context of the time that this was written in. They do not have to be perfect. They're always in flux, and we understand that, but they can be used as like historical artifacts to understand why we didn't take a more obvious path at the time. So all of these are clues we're leaving to relate intention to future developers, just giving ourselves the best chance of maintaining these complex systems as possible. And now that we've discussed those patterns in a code base, I want to talk about patterns on a team. This is me at Flatiron when we all dress spontaneously alike. And I just thought it was a really funny photo. So developing a pattern on a team is not about losing our creativity or individuality, or that we can't introduce new ideas. It's mostly just growing a shared vocabulary to make us more productive and more efficient. This actually was a team I worked on where the 4 women in this photo are Elixir developers. The guy in this photo is from another company whose team did not write Elixir. And we had this 3-month project that we worked on together where the 4 of us we were all writing Elixir code, and we were teaching as we were going along with these other developers. And 2 of us are juniors, including me, but we were able to use Elixir to create this shared context and go along. We moved really fast, and we were super efficient with the work that we were doing because we were constantly developing these shared conventions and talking through it as we were going. So that was a really interesting experience. And I think Elixir does lend itself to writing this code that even though it's not strict about the conventions, you can create these together. So to help us maintain these patterns, we're going to want several methods of broadcasting and reinforcing the conventions that we're creating together. These can be broadly applicable to teams in any language, but there's a couple of Elixir specific things that I think about when I'm thinking about maintaining these for Elixir teams. It's still newer. It has a growing but smaller amount of resources than established languages like Ruby. So people are relying more on the team to understand what conventions we're using. Elixir doesn't force conventions. We need to build that pattern and that muscle with our team. Elixir can be misunderstood as a language that's only valuable when using it for heavy concurrency or processing. But it is a fantastic framework for just general web applications, and we should be encouraging adoption there. And it's been a gateway from object-oriented languages, especially Ruby, to functional ones. And since we know this, it's helpful to focus on that perspective when we're planning out how to introduce it to make it more accessible to other people. So with that in mind, I want to group people and behaviors that can help us form these team patterns into 2 broad categories, which is onboarding and maintenance. Within onboarding, there's a couple of different roles. There's a champion, a teacher, and a buddy. These are 3 archetypes that I think about when we're talking about onboarding new people. So in smaller teams, this might be 1 person. Larger teams, they can be spread out. But for members new to a team or developers to Elixir, these are the people that are going to help them gel with the team the fastest. So the champion is somebody who is an advocate for Elixir. someone that makes you excited about building it. And this was really important when we were transferring our entire team to become Elixir developers at Flatiron School, because we were starting to build microservices in Elixir from a Ruby monolith. And there was one person that was just so excited about it and like really championed it for all of us. And he was not there to teach all of us necessarily, but he was there to get us excited about it. And I think that in that context, if you are transferring a team, that you need that person who's just going to be pumping up the rest of your team about how cool this is and what this is going to be like for all of you. The second one is the teacher, and this is for people who are onboarding to an Elixir team who are not Elixir developers, which we need. We're never going to be able to just hire Elixir developers for the projects that we want if we want our language and our community to grow. This is from a slide deck I made when I was at Frame.io about transferring Ruby developers to Elixir, because that's what we were seeing most often. And like I said before, if that's what you're seeing, like make something that is going to speak to those people. So this was a session where we just introduced functional concepts at a high level, talked about the Ruby to Elixir pipeline, gave people a mental model of where to start, and gave them some resources and patterns they could start looking at. And lastly, the buddy. These are my cats. They're not very good at coding, but they are emotional support when I'm doing it. And so this person is not like a mentor necessarily or a teacher. It's somebody that is feels like a peer that you're not going to be judged by. It's not your manager. It's someone you can reach out to and say, hey, I'm struggling with this and I don't want to ask it in a public channel. Like, can you help me? It is my feeling that we should make our public channels extremely low friction so that people do ask in public channels, but you might not have that and you want those people to still feel empowered to ask for help when they need it. They can pair, they can just feel like more of a tour guide around the code base. And I just think that that's been one of the most helpful things, is just designating someone for a new Elixir developer who's there to answer what might feel like stupid questions to them. And so all of these people become maintainers of your team conventions, which is what we're going to talk about now, is maintenance. So outside of the onboarding experience, teams can create their own ways of reinforcing these patterns together. And this is some people in my current team at NOC. So we've got things like a book club. This has worked really well at some places I've worked, and I have not joined at other places. Depends on what you're doing and what you're learning. I think the best time we used it was when we were all ramping up to Elixir and working actively on a project together. And so we read these books, then implemented the patterns together. Otherwise, it didn't work for me necessarily, but I think it works for other people if you're just exploring things. Pairing on a big enough team is excellent. This is something that can really help those patterns reinforce within your team and align the way that you're thinking with someone else. Architecture and PR reviews, these have also varied at different companies, but any large feature should be asynchronously written up so that other people can see what we're doing and share knowledge around it. And then a shared conventions doc is super helpful. This is something we have at NOC. We keep this Notion doc that we keep updated. It's longer than this, but you can kind of see some of the things that we jot down. It's pretty ad hoc, but it's nice when we're talking about things in PR reviews and deciding together how we're going to handle it. It can help us bring up norms and decide those together. We also have a Learn Elixir Slack now at NOC, which is great because we're starting to hire non-Elixir developers onto our team. And what I mentioned before about like this open Slack channel idea is like, we were noticing that people were asking questions about Elixir in our engineering channel or in our project channels. And if we can put those all in one place, then other people who join can easily search that channel and get the information that other people were already asking about. And it also empowers everybody to feel like there's no stupid questions when it comes to this. Lastly, I'll call this out. If we're relying on behavior only to enforce these patterns, we're going to eventually lose those patterns because people are not machines. And the more we can give robots to do, the better our success will be. So this is a pretty small list of tools that can help us automate some of these patterns. But other people have brought up more to me as I've done this talk. So I would encourage you to look around at what would help your team the best in terms of tools that can help you. And I'm imagining some of you already use some of these, but they are helpful to keep reinforcing your patterns. And as our community and ecosystem grows, this list is obviously going to grow with it. So that's basically everything that I wanted to cover today. We've talked about patterns in a code base, why having them can help us grow stronger and faster, certain team behaviors that can help reinforce that. But there's one more thing that I want to leave you with that I think is probably the most important piece of all of this, which is that when you create and maintain clear patterns in your code and build a team vocabulary, you're part of this bigger movement, which is democratizing software engineering. We want our industry to be accessible. We want it to be welcoming. We want it to be diverse. But our demographic is, at least where I am, still pretty male and pretty white. And it's still made up of people who knew that they wanted to build software engineering from a young age. And it's still mostly accessible for people who came to it through academic routes, even though boot camps have become much more accepted in the past 2 years. And it's obviously like those people are the important people that are building a lot of these applications today. And we don't want to lose those people, but we want to make space for other people to join us in a career that's very rewarding in so many ways. One of the biggest hurdles to this is that when one community has been in the majority for a long time, I've seen that they develop an unspoken understanding with each other. And it's not to gatekeep others, it's just because it's convenient and everybody has automatically created this shared vocabulary. There are definitely times where I've been told that I should have just known how something was done. And I've been in that position of trying to guess what those patterns and protocols should be. So basically, patterns and processes feel like a burden to people that already know them because they've created them together. But without them, it does tend to keep another group of people from reaching their potential on a team because we force them to guess instead of giving them the answers that we already have. And it leads to this perception that the second group isn't as capable when really they're just starting at a disadvantage. So at best, this is inefficient from a business perspective because now we have a portion of our team that can't fully participate. But at worst, this unintentional exclusion does contradict the values that we share as a community. There are many factors to this problem that are outside the scope of this talk, but we can do our small part within our organizations to move the needle by not expecting people to know what they were never told. So writing down our protocols and processes so that everyone can access them. And by setting up and communicating patterns so that people can start on the same footing. And by writing code for our future teammates and for our future selves to read and understand. And by being superstar developers by prioritizing building up our team as much as we do our product. So to me, that's what good behavior looks like. And this is the kind of company that I want to keep. Thank you. That's it. Thanks, everybody. I think we still have about 10 minutes for questions. I don't know if anybody wants to chat or share thoughts. Thanks, Adolfo.
Yeah, thanks a lot. That was a fantastic talk.
Thank you, Petrus. Petrus, is that the way you say your name?
Yes, Petrus, like Tetris almost, is a completely fine pronunciation. In Afrikaans, it would be Petrus.
Oh,
But
that's nice.
Yeah, people often mistake that for Beatrice.
Beatrice?
Yes.
Yeah, I
so
can see
Petrus is easier. Can I pop a question?
Yes.
Well, firstly, just a quick comment. I really liked your naming that you shared for the filter functions, because I've been coding up some filters myself, and then the names become really boring and generic, like filter by field, but
Yes.
If you just say filter by field, it doesn't say is it an equality filter, is it larger than, bigger than, is it Boolean?
Yes.
So if you have some kind of convention like you were suggesting about like filter for year, then it's kind of obvious that it's a equality on that field. And I like that. So thanks a lot for sharing that. That's a nifty idea that I'm definitely going to apply.
Oh, good. I'm so glad.
And I wanted to ask about the tooling. So you spoke about doing like internal documentation. One thing you mentioned was architecture diagrams. Now,
yes.
Do you have some specific tool that you use for doing that makes it easier? Because those kind of things can be quite complicated, right?
Oh, for sure. Yeah. So I think that the best tool for me that I've seen and what our team uses right now is a low barrier to entry drawing tool called Excalidraw. I don't know if you guys
Okay.
have seen this. I will put it in the chat so you can. Excalidraw.
Is the X for Elixir, or is it just a
No.
fancy?
Well, not that I know.
Okay.
It might be built in Elixir, but I don't know that. And the reason I like it is because it is just so easy to get going with it. It's very simple tools. It's like simple colors, simple lines, simple shapes. And we use it pretty consistently on our team when we're creating system architecture diagrams. And I find it to be a little bit less effort than making like a UML diagram or something like that. And it's also more, it's easier to change as things change, just because it's visual. So I'm just using,
Okay.
you know, my mouse to move it around. So that is one of the tools that we use is that to describe like all of our system diagrams right now.
And you're probably starting with some existing system diagram and then just changing it a bit for whatever you're trying to propose on some pull request or something like that.
Well, that's a good
or not.
question. I think like in terms of our system right now, there's a lot of new greenfield features because we're a newer, you know, code base.
Okay.
But we have built up these system architecture diagrams about like various pieces. So it's more just like taking, okay, so from this piece of our notification system, we're going to be building this other thing, you know, and we create like a new diagram of what this new flow will be, essentially.
Cool.
So that goes alongside these tech briefs that we create that have like the system architecture diagram, probably like a relationship entity diagram, and like a list of vocabulary that we're using, which I think like the vocabulary part has been really useful because when we're talking from product and design all the way to like our infrastructure, aligning how we're speaking about these things can also help inform the user experience. So when I say customer, am I talking about our customers or am I talking about their customers? Like that is a word that we need a definition for. And so we write down these like words that we're using and define it as we're going, just so that it can be like, because I mean, I think I've definitely worked on projects where we get halfway through and we're like, oh no, we haven't been talking about the same thing this whole time.
Yes.
Yeah. And so like, I don't know, it feels like really obvious when you say it out loud, but I've definitely run into this before.
Language is important.
Yeah.
Yeah.
Wow.
Cool.
That was more than an intriguing conversation that we managed to give us, Mary. We are really thankful, we're really grateful. Now we understand what good behavior actually in definition means. I'm certain that all of us are actually impacted very greatly by the fact that you've actually granted that. Thank you for that. I want to really appreciate everyone for joining us for this call. We hope that it has greatly impacted your lives as much as it has for me. And do have a lovely rest of the day. Can't wait to see you on the next one. Bye-bye, guys.
Thanks, everybody.
All right.
Nice to meet y'all.
Cheers.
Bye.
Keep well. Thanks for the talk.
You too. Thank you so much. Bye.
Bye. Thank you, Mary.
Thanks.